Hi guys, let's have a look at some quadratic expressions, and specifically we're going to look at expanding algebraic expressions in this session, okay? Now, let's get underway. A binomial expansion, okay, what does that mean? Well, when an expression contains two sets of brackets, the expansion is known as a binomial expansion. You'll see what I mean when I show you this diagram. Now, look at this diagram. We've got a rectangle there, and this side here is made up of an A to that boundary point there, plus B over there to the end. From the boundary point of the end of A over to the end is B, okay? And then the side of this rectangle is made up of C down to there, plus D down all the rest of the way, okay? Now, if we were to get the area of that rectangle, that would be A plus B times C plus D. Now, that's fair enough, isn't it? So really we want to find what A plus B times C plus D is, because that's our area, okay? That's our objective. Now you can see that this rectangle's now been very, very cleverly divided up into four coloured segments. And you can see that this red one is A plus, oh, it's not A plus, it's A times C. Yes, A that away, C that away, okay? This yellow one is A across the top there times D down the side, so that's AD. Similarly, this one here is B times C, and that blue one is B times D, okay? So the amazing thing is that basically the diagram visually shows that A plus B times C plus D equals the sum of those four individual shapes inside there, those rectangular shapes inside there, which are AC, the red one, plus AD, the yellow one, plus BC, the white one, plus BD, the blue one. That is called the expanded form. We've got rid of the brackets. There's no brackets there anymore, as there are on the left-hand side. This is the expanded form. Okay, so that's very interesting. Now, generally speaking, binomial expressions contain only one variable together with constants, and I'll show you what I mean. Have a look at this one here. Expansion of the binomial expression x plus 3 times x plus 2 can be shown visually in a similar way by this area model below. Now, this one, these terms in here in the brackets only have one variable, being the x term, and then a constant, okay? Instead of A plus B times C plus D, we've just got x plus 3 times x plus 2. One variable and a constant in each bracket, okay? But you can see very clearly by looking at the same kind of analysis as we did on the previous screen that x plus 3 times x plus 2 similarly yields the four little rectangles, okay, that we had before. This one is x times x, or x squared. See, it's x across the top, x down there, so that's a square, that one. This yellow one is x across the top times 2 down the side, so that's 2x. This one similarly is 3 times x, and that one there is 3 times 2, which is 6. Okay, so therefore we're saying that x plus 3 along the top times x plus 2 down the side gives you these four individual squares or rectangles or squares in that case. That red one's a square. That gets us x squared, the red one, plus 2x, yellow one, plus 3x, blue one, plus 6, the white one. Okay, so when you then collect those like terms, the 2x and the 3x terms, you collect those, they become 5x. So therefore, this beastie here, x plus 3 in brackets times x plus 2 in brackets equals, quite clearly from our visual cue up here, it equals x squared plus 5x plus 6, doesn't it? It's fascinating, isn't it? Okay, now, Obviously, ladies and gentlemen, it is not necessary to draw this area model every time when we're expanding binomial expressions. The shortcut method is simply to multiply each term in the first bracket by each term in the second bracket. But I think it's very important to know where this kind of thing comes from a visual perspective. At least for my brain it is anyway. I really appreciate that, and it makes a lot more sense to me if I can understand it in more than one way. Okay. Alright, now what's this? We're going to expand these things. Okay, well I'll show you how I do them, okay? And hopefully you'll get something out of that. This is the first one. Now, what I do is I multiply, as I'll show you. That would equal, now that's the first term, that's the x times the first term there, which is also an x, so that gets you an x squared. Okay, then I multiply the next time I multiply that x by the second term in that bracket, okay, that gets me 2x, okay. Now we'll start by multiplying the 3 by each of those terms there in that second bracket, so that the next term becomes 3 times x, and then the last term becomes 3 times 2, which is 6, okay. So now we'll collect our like terms and just simplify that a little bit, so it becomes x squared plus 5x plus 6. Yes? That's how you do it. Nice, isn't it? Okay, what about this second one, number B? Same procedure, guys, same procedure. So let's go with it. That would be x times 6, or 6x, and then the second term would be x times negative x, which would be negative x squared. The third term would be minus 7 times 6, which is minus 42. And the last term would be minus 7 times minus x, which would get us plus 7x. Okay? Yes? Now, clean up time now, guys. Collecting the x-like terms. We are going to get 6x minus x squared minus 42 plus 7x. Now, cleaning up, as I said, that'll be minus x squared plus 13x minus 42. Okay? Yes, are you happy with that? You usually put the x squared terms first, the x terms second, and the numbers last. Okay, that's the convention. Alright, what's this? FOIL method. Yeah, the FOIL method is just another way that you can use, if you like, to multiply these binomial terms out, expand them out and get rid of the brackets, okay? So, firstly, the F stands for first terms. So you multiply both of the first terms together. Then the O stands for the outer terms, outside, multiply them next. Then the I stands for the inside terms, you multiply them next. And then the L stands for last, you multiply the last terms next. Okay? F-O-I-L, front, outside, inside, last. Okay? Or I suppose that front could mean first. So it could be first, outside, inside, last. Alright? Now we're going to use the FOIL method to expand this thing. Off we go, okay? F, now that's the first, so that'll be x times x, which is x squared. O is outside, so that would be, what would that be? Come on, you have a think. Yes, it would be those two multiplied together, which would be minus 5x. Now we've got the I for the inside, what would that get you? Yes, it would. It would get you plus 2x, and then L for last would get you minus 10, wouldn't it? So therefore we're saying that this thing expands to get that, and we just have to collect these like terms here. And what do we get? X squared minus 3x minus 10. Jolly good show. Now, if there is a term outside the pair of brackets, we simply proceed as normal by expanding the brackets, and then we multiply each term of the expansion by the term which is outside the brackets. I will show you what I mean in case that confused you. See, look, here's the term outside the brackets here. See it? Yes, you get that. So what we're going to do is we're just going to multiply all this out, expand it out, this x plus 8 times x plus 2. Then when we finish doing that, we're going to multiply the whole thing by 3, because remember our objective is to expand and get rid of all the brackets, okay? So let's do the binomial thing first, okay? This is the way I do them. X times x, then we've got x times 2, or 2x, then we've got 8 times x, yes, and then we finally get 8 times 2, which is 16. Now, that if we just collect those like terms, you'll get x squared plus 10x plus 16, and I'm going to multiply that whole thing by 3, okay, because that's what we're trying to do. That's right, that's what it is. Now, come on, we expand out that bracket now. So it's 3x squared, isn't it? You keep going, yes. Plus 30x plus 3 16s are 48. And thank you, Mr. Box. There it is. Yes? Yes, that's what it is. What else we got for you? Perfect squares. Are you aware of the perfect square? Well, I'll show you. A special binomial expansion involves the expansion of perfect squares, okay? And a perfect square simply means something multiplied exactly by itself, okay? Now, what have I got here for you? What have I cooked up here? Well, I see what I've done. This is a plus b along the top and a plus b along down the side. So it's really a plus b all squared, the area of. And if you go through a similar analysis as we've done now twice before, you'll see that this yellow one is a times a, or a squared. The white one is b times b, or b squared. Then we've got a times b and a times b. Oh my goodness, isn't that amazing? These are both the same size, exactly the same shape, except they're just one's orientated around in a different direction compared to the other one. I see it now. So therefore we've got a plus b all squared is a squared, that's the yellow, plus ab the red, plus ab the blue, plus b squared the white. Collecting these middle terms here, we get a squared plus 2ab plus b squared. Well, blow me down. So this result tells us, guys, that to expand a perfect square, this is the shortcut method of doing it, guys. You square the first term, okay? That's a squared, right? Then you multiply the two terms together, that is a times b, and then double the, them, which means, what did I say? A times b times 2, which would be 2ab, right? And then you square the last term, which would be b squared. So what is it? It's a squared plus 2 times a times b plus b squared, okay? Yes, that's what it is, okay? And you'll get very used to that in time, because that's really important to know that. And it helps to remember that, because you just use it so very often, okay? And similarly, guys, a minus b all squared is done in the same way. You square the first term, a squared, and then you multiply these two terms together, which gets us minus ab, then multiply that by 2, that's minus 2ab, and then you get b squared. Yes, that's what you do. Mighty fine. And of course, any perfect square can also be expanded using FOIL. Yes, the FOIL technique, first, outside, inside, last, as we were doing before. However, this method that we've just showed you there provides a quicker alternative for performing such expansions if you care to remember the procedure as to what you do. Right? So a plus b all squared is a squared plus 2 times a times b plus b squared, or if you like, a minus b all squared is a squared minus 2ab plus b squared. And I think Mr. Box is champing at the bit. Yes, thank you, Mr. Box. They're very, very legendary Academy Award winning formulas, those ones. So thank you. Right, let's have a look at this. What are we doing here? We're expanding and simplifying the following. Two perfect squares, if ever I saw them. This one's got a minus 3 in the front of it, but that won't cause us any grief. Oh no, we know what to do. So let's do A first. Okay? Hello, A. Today, hooray. So that would get us. Now come on, do you remember what to do? Well, it's the first term squared. Yes, that's a perfect square. Thank you, Mr. Computer. It's the first term squared plus 2 times the first term times the second term plus the second term squared. That's the quick way of doing it, guys. Now, if we just pretty that up a bit, we will get 4x squared minus 20x. That's 2 times 2 times 5 is 20, and it's a minus, Remember, there's a plus here and a minus there. The signs are different, so the answer's minus. So it's minus 20x. And this is plus 25. The minus times the minus gets you a plus, yes? Are you right? Yes, very good, okay? You get that. NB, yes, of course, the conventional method of expansion could be used if you really prefer, but I think it's quicker to do that. But if you really insist, I will show you, all right? So, there we go. That's, what is that? 4x squared, yes. And then we get minus 10x, I think it'll be. And then the next term will be also minus 10x, and the last term will be plus 25, okay? And there it is. So what is it? It's 4x squared minus 20x plus 25, which is exactly what we got up there. But see, it's quicker to do it this way if you just remember what to do, guys, for perfect squares. Yes, it is. All right. Okay, B for you and me. Well, this one, we're just going to do the perfect square first, and then I think we'll multiply it by minus 3 after that. Yes? Okay. So, yes, it's a perfect square. Yes, we're aware. It's a perfect square. So, there. Now, we're going to... what have I said? Oh, yes, here it comes. We're just going to square that. That's 2x all squared, plus 2 times 2x times 7, plus 7 squared. Yes? Now, let's just pretty the inside up a bit. There it is. 4x squared plus 2 times 2 is 4, 4 7 to 28, so it's 28x plus 7 squared, which is 49. Now we're going to get rid of the brackets, because remember, we're expanding, so we're getting rid of all brackets. So we're multiplying everything in here by the minus 3. Wow. Does that look right? 3 times 28 is apparently 84. And 3 times 49 is apparently 147. And you'll notice that they're all negative. See, this is negative times a positive gets you a negative. Negative times a positive gets you a negative. And a negative times a positive here also gets you a negative. And a thank you, Mr. Box. Okay, that's very excellent. Now, this is the difference of two squares rule, okay? This rule results from the expansion of an expression of the form a plus b times a minus b. So it's not a perfect square anymore. These signs here are different, okay? One's a plus and one's a minus, and the front terms are the same in both brackets and the rear terms are the same in both brackets, okay? So the two brackets contain the same terms, but one has the terms added and the other has them subtracted, as I was just saying. Now, so expanding that, guys, I will show you. What you'd get is a squared, yes, okay? Then you'd get minus ab, okay? Then you would get plus ab, or plus ba, same thing. And then the last term you would get is minus b squared, wouldn't you? There she be. Yes. Now let's just pretty that up a bit. Now you watch and see what happens here. That gets you a squared minus ab plus ab minus b squared. Now look at this. Look at this. These middle terms are going to cancel each other out. Yes, and you're just left with the difference of two squares. You see, this square take away this square means that's the difference when you take something away from something else. So that's a squared minus b squared, okay? Difference of two squares, okay? NB, the middle two terms in a difference of two squares expansion always cancel each other out. Always cancel each other out. There's never any middle term, okay? So, if you have anything of the form of a plus b times a minus b, it equals this difference of two squares. That's what I'm saying to you. Okay? That's what it becomes. Okay? Now let's just do some practical examples of this, and look, they're definitely differences of two squares. You've got 3x plus 1, 3x minus 1. This one here is 2x minus 7 times 2x plus 7. So they're definitely differences of two squares, as we will expand them out, being aware of that, except this one has to be multiplied by 4, but that's no problem. Let's do them. Here is a Okay, right now, you tell me, what do? We don't need to expand it out using the usual long method. We can just recognise that it's a difference of two squares, and therefore we can say it's the first term all squared minus the second term all squared, which is what I've done, exactly what I've done. So 3x all squared is 9x squared, and it's minus 1 because 1 squared is 1, and that's your answer. And thank you, Mr. Box. Okay, differences of two squares. Very, very easy. You just got to recognise them. B, okay, this one's the same deal, except we're going to multiply by 4, but we'll do that at the end, okay? So we've got 4 times 2x minus 7 times 2x plus 7, and that gets us 4 times 2x all squared minus 7 all squared. Now let's just pretty that up a bit. So it's 4 times 4x squared minus 49, and now we will get rid of that bracket by multiplying both terms inside the bracket by 4. So it'll be 16x squared minus, what's 4 times 49? Well, 4 times 50 is 200. Take away 4 would be 196. Yes, there it is. And thank you, Mr. Box. There you go, guys. Look, it's very exciting, and you have to agree with me. Oh, well, I think it's very exciting. Now, here's the remember. We're nearly at the end now. So when expanding an algebraic expression with one bracket, you multiply each term inside the bracket by the term outside the bracket. If we have two brackets, then you multiply the terms in order. First terms, outer terms, inner terms, last terms, or the way that I showed you, which is the way I prefer to do it. But that's the FOIL, okay, the FOIL technique. Now, if you have a term outside the two brackets, expand the pair of brackets first, and then you multiply each term of the expanded expression by the term outside the brackets, e.g. what we were doing before, yeah? Well, we were doing that before. Okay, if you have three brackets, well, goodness gracious me, we didn't learn how to do that in this exercise, but what you could do is you could expand any of the two brackets, yes, which you know how to do by now, and then multiply the expanded expression by the third bracket, okay? That would be very sensible. Now, the perfect squares rule, yes, that's that thing. That's a perfect square because it's something, a binomial thingy multiplied by itself, yes? So that's a squared plus 2ab plus b squared, or if you have a minus b all squared, it's a squared minus 2ab plus b squared. And last but not least, the differences of two squares. If you have something of that form there, a plus b times a minus b, it is just going to be a squared minus b squared, because you never ever end up with a middle term when you expand this thing out, okay, because they cancel each other out as I showed you. Right, I think that might be the end. Yes, and the end is your friend. Okay, well, I hope you enjoyed that, and I really, really do hope you got something out of it. Go back and have another look if you need to, but please do plenty of practice because that makes perfect, all right? And we'll see you soon. Okay, bye for now.